Hello everyone, welcome back to our channel. We are back again with a new video. In this video we are going to create a lava flow map from Volcano Pattern using Python. So let us start this by importing the required libraries. So here matplotlib.pyplot is a plotting library for visualizing data, and we'll use it to create the heat map of lava flow. And NumPy is a powerful library for numerical computation, and we'll use it here to create arrays and perform mathematical operations. And now we'll define the grid for terrain. So here size is equals to 300, so we define the size of the grid. This will create a 300 into 300 grid of values, that is 300 points in the both x and y direction. And np.linspace, so this creates a 1D array of size points that are evenly spaced between -5 and +5 for both x and y axis, and this represents the geographic area of the map. And np.meshGrid, this converts the 1D array x and y to 2D grid capital X and Y. So this represents the terrain coordinate where each point corresponds to a position in the XY plane. Now we'll simulate the volcano peak. So this line creates a volcano peak at the center of the grid at the point 0 and 0. The function np.exponent is a Gaussian function which produces a bell-shaped curve. So the center of this curve is at 0 and 0 where the volcano peak is located, and at the center the value is 1, so which is the highest point. As you move away from the center, the value decreases exponentially, simulating the decreasing elevation as you move away from the volcano. Now we'll simulate the lava flow. So here distance is equals to np.sqrt. This calculates the distance from each point on the grid to the center 0 and 0, which is where the volcano is located. So this helps determine how far each point is from the volcano's peak. And np.exp, this part simulates the lava flow. As the lava moves further from the volcano, it loses intensity, means it cools down. So the exponential decay represents the cooling effect, and the value is higher near the volcano and gradually decreases as the distance from the volcano increases. And here lava flow, this line combines the lava flow decay with the volcanic peak elevation, and the lava is more intense around the peak of the face as it spreads outwards, creating a more realistic lava flow pattern. Now we'll add terrain noise. So here np.random, this generates a random noise array with the same shape as lava flow, and the values are between 0 and 1. And 0.05 into np.random, the noise is scaled by 0.05 to ensure the noise isn't too overwhelming, so this makes the lava flow look more irregular and natural. And lava flow plus is equals to terrain noise. Here the noise is added to the lava flow array, creating small variations in the lava intensity across the grid. Now we'll plot the lava flow map. So here plt.figure creates a new figure with a size of 8 into 6 inches, and plt.im show here the lava flow represents that this line is the data where lava flow map that we want to visualize, and cmap is equals to hot. This specifies the color map for the heat map, and the hot color map uses red, orange and yellow to represent high values and black for low values. And extent, this defines the axis limits. The plot will show the terrain from -5 to +5 in both the x and y direction, and origin is lower. It means this sets the origin of the plot to be in the lower left corner, and this is common for maps and geographical data. So here plt.colorbar adds a color bar to the right of the plot showing the lava flow intensity values, and the label explains what the color bar represent. And plt.title adds a suitable title to the plot, and plt.x and y label sets the representative labels to the required label grids, and plt.grid disables the grid lines on the plot for a cleaner image, and plt.tight layout ensures that the layout is adjusted so that the elements are properly spaced and not cut off, and plt.show displays the plot. So here we can see a lava flow map from Volcano. So thanks for watching this video.